Hi students, in previous class we are discussing classification of elements. Three types of blocks is over: S block, P block, D block. Now we are going to discuss about F block. Now we are going to discuss about F block elements. Okay, so here F block elements we are going to discuss. F block elements. In F block, two series are present. It is F block. Okay. In F block, two series are present. It is one series which is nothing but a 4F series. It is one series which is nothing but a 5F series. So, it is in sixth period, it is in seventh period. Okay, P means period. 4F series starts with lanthanum, means after lanthanum starts with cerium. Okay, ends with deuterium. Its atomic number is 58. Its atomic number is 71. Next 5F series starts with thorium, atomic number 90, and ends with lawrencium, atomic number 103. Okay, these are called, see, if you see sixth period after lanthanum, 14 elements are called lanthanides. How many elements these are? 14 elements. These are how many elements? 14 elements. After lanthanum starts with the cerium, ends with the deuterium. These elements are called lanthanides. Lanthanides. If you see seventh period after actinum, 14 elements are called actinides. Actinides. These are lanthanides, these are actinides. So, this is about F block elements. See, I am going to explain by point wise. The valency electron enters into F orbital are called F block elements. That is first point. Valency electron enters into F orbital are called F block elements. These are called inner transition elements. Inner transition elements. These are also called inner transition elements. Why these are also called inner transition elements means they are present in the transition elements after lanthanum, which is belong to the transition elements are 4 series: 3D, 4D, 5D, 6D. If you take 5D series after lanthanum 14 elements means these are present in transition elements. That's why these are called inner transition elements. Okay. Then this F block contains two series. Two series. That is 4F and 5F. The 4F series are called lanthanides. 4F series are called lanthanides. Okay. Starts with the cerium 58 to deuterium 71. Next 5F series are called 5F series are called Here 4f series are called, 5f series are called actinides. Actinides. 5f series are called actinides. Okay, and then general electronic configuration of these elements. General electronic configuration, general electronic configuration is n minus d 1 to 10. This is a d, n minus d 1 to 10, ns 1 to 2. These two, it is sorry, f block now. So general electron configuration is n minus 2 f 1 to 14, n minus 1 d 0 to 1, ns 2. So here it is a ultimate shell, it is a penultimate shell, it is a anti-penultimate shell. So these three shells are incompletely filled. These three shells are incompletely filled. This is a general electronic configuration of f block elements. They may form compounds due to high reactivity. They may form compounds. So this is briefly about f block elements. So here the differentiating electron enters into f orbital are called f block elements. So these are also called inner transition elements. Next, in this f block two series, that is two series are present, that is 4f and 5f. 4f series are called lanthanides, 5f series are called actinides. 4f series starts with the cerium, ends with the deuterium, 14 elements, and 5f series starts with the thorium, atomic number 90, ends with the lawrencium 103, are called actinides. General electron configuration is n minus 2f 1 to 14, n minus 1d 0 to 1, ns 2. Means total 3 orbitals are incompletely filled. Okay, so this is briefly about a f block elements. See students, very important this classification. So one more classification we are going to discuss, that is nothing but classification of the elements based on electronic configuration. One more classification we are going to discuss, that is classification of elements based on electronic configuration. Electronic configuration. Okay. This is based on differentiating electron or valency electron. It is a classification based on how many electronic configuration. Okay, so there are 4 types. There are 4 types. Okay, the first one is noble gases. First one is noble gases. The second one is representative elements. Representative elements. Okay. Third one is transition elements. Transition elements. And fourth one, inner transition elements. Okay. The first we are going to discuss about noble gases. See, first one, noble gases. Okay. So noble gases means group 18 elements are called noble gases, which are present in the end of the periodic table. See, first one, group 18 or 8th A are called noble gases. Are called noble gases, or aerogens, which are present in the air, or inert gases which do not have any chemical reactions, like this. So group 18 or 8th A are called noble gases. So general electronic configuration is ns2 np6. General electron configuration is ns2 np6. Due to presence of stable electronic configuration, they are chemically inert. They are not participating in chemical reactions. So due to this they are chemically inert. They are chemically inert. Inert is nothing but inactive. Okay. So due to this they are chemically inert. Next, their ionization enthalpies are very high. Ionization enthalpies means removing electron from their valency shell. Ionization enthalpies are very high. Ionization enthalpies are very high. Okay. So this is next, electron gain enthalpies very zero. Electron gain enthalpies are 0. Electron gain enthalpies means gaining of electrons. Capability of gaining of electrons is 0. That is we are going to discuss briefly in next classes. So this is about noble gases. Okay. So group 18 or 8th A group elements are called noble gases. General electron configuration is ns2 np6, which are present in the end of the periodic table. Next, due to ns2 np6 they are chemically inert. Chemically inert means they are not interested to participate in chemical reactions. Ionization enthalpies are very high. Ionization enthalpy means if you remove one electron from these group, then amount of energy required is very high. The amount of energy is called ionization enthalpy. Okay. Next, some more points here I have to write. Electron gain enthalpies. Electron gain enthalpies are 0. Electron gain enthalpies are 0. If you add the electron taking capacity is 0. And then what are the elements present in this group means helium, neon, argon, krypton, xenon, radon. How many elements are present? These are noble gases: helium, neon, argon, krypton, xenon, radon. Okay, so this is briefly about noble gases. Next, the second one is nothing but representative elements. Representative elements. The second one we are going to discuss, that is representative elements. Okay. What are representative elements means the S and P block elements except 18th group, except 0 group or 18th group are called representative elements. Okay, see, the S and P block except 18th group, except 18th group, S and P block elements except 18th group are called representative elements. These are called main shells element. These are called important elements or main shells element. So how many groups are present in these means how many groups are present means see, first A, second A, third A, fourth A, fifth A, sixth A, seventh A are called representative elements. The general electronic configuration is general electronic configuration NS to NP1 to 5, NP1 to 5. These two are partially filled, NS to NP5. So due to this, they are chemically active. Due to this, they are chemically active. Okay, they form ionic compounds. They form ionic compounds and covalent compounds. Okay, they form ionic compounds. Why? Because they having unpaired electrons in S and P. So they form ionic compounds and covalent compounds. Next, the S representative elements contains metals, metalloids and non-metals. Metals and metalloids, comma non-metals are present. Okay, metals, non-metals. First A, second A group elements are called metals. Third A, fourth A group elements are called metalloids, which having 50% metallic and 50% non-metallic. Fourth means fifth, sixth, seventh group elements are called non-metals. Okay. Their electron gain enthalpies are zero na. They are having electron gain enthalpies and electropositivity values also. Okay. So this is about representative elements. These are main shell elements or main elements. Okay. This is briefly about representative elements. Representative elements. Okay. Next, how many groups are present in this one? So 1, 2, 3, 4, 5, 6, 7 groups. It is based on electronic configuration classification. Okay. Then third one is transition elements. Transition elements. So what are transition elements means groups 2 to 13 groups. 2 to 13 groups are called transition elements. Groups 2 to 13. 13 means 12. 12. 13th group is this one now. So 12 are called transition elements. Okay. Groups 2 to 12. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 groups total are called transition elements. Okay. Their general electronic configuration is n minus 1 d 1 to 10 ns 1 to 2. This is general electronic configuration. So due to this general electronic configuration, they have some typical properties. Typical properties. Typical properties means special properties. They form alloys. They form alloys. Next, they form complex compounds. They form complex compounds. Next, they show magnetic properties. Magnetic properties. Next, they form colored ions, colored compounds. Okay, all these are typical properties. All these are typical properties. Alloy means two or more metals combining. The mixture of two or more metals is nothing but alloys. Complex compounds means big molecules are nothing but complex compounds. We are going to discuss later. Complex compound which having a central metal atom which is a D block, next ligand, next anion or cation. The combination of all these is nothing but complex compounds. We are going to discuss in second year. Next, magnetic properties. Magnetic properties means ferro, para, dia. How these properties means? So all these typical properties are due to presence of unpaired electrons in their d orbitals or in the d subshells. Okay. So colored compounds. They may give colors, different colors, and variable oxidation states and catalytic properties and formation of industrial compounds. All these are characteristics of transition elements or typical properties of transition elements. It is very important. Okay, so noble gases is over, noble gases is over, then representative elements is over, then transition elements is over. Now we are going to discuss about inner transition elements. Next, what is inner transition elements? So inner transition elements is nothing but F block elements. Already we discussed previously, so that is the topic we have to discuss here. So once again I am explaining. Classification of elements based on electronic configuration is 4 types: noble gases, representative elements, transition elements, inner transition elements. In noble gases are also called aerogens, inert gases, and noble gases. Why? Because they are present in the air. Air contains nitrogen, how much? 78%. Oxygen, how much? 21%. So 1% is noble gases, fresh air. Next, representative elements, transition elements, inner transition elements. Okay, so this is briefly noble gases, and it is briefly about representative elements, and it is briefly about transition elements. See, you see students, one thing you have to get the classification, means you don't confuse when you are going to face this question in board exam. So classification of elements into SPDF blacks, that is a different. Classification of elements into based on electronic configuration, this is a different. So you don't confuse when you are going to answer this question. Based on differentiating electron, elements can be classified into 4 blacks: S, P, D, F. Based on electronic configuration, elements can be classified into 4 types: noble gases, representative elements, transition elements, and inner transition elements. Okay, and then the balance inner transition elements we will discuss later. So what we discussed in this class means F block elements and noble gases and representative elements and transition elements. Okay, so when you are going to write general electron configuration, don't confuse. Here in transition elements, second B group is not considered as a transition element, that can be considered as a D block elements. Okay, so here how many groups are present? 10 groups. So general electron configuration is this is a general electron configuration, and here it is a general electron configuration 1 to 5 only. Here it is a N2, NS2, NP6. So each and every point you have to get, and what is explained by me, you have to try to finish time to time. Try to finish time to time. Okay, so this is today's class. Okay, leaving.